Welcome to part two of this lecture on skin and eye diseases. This is a lecture that I'm doing for my college students who are in an introductory microbiology course. Again, we're looking at skin and eye diseases. I just covered in part one bacterial skin infections. We're going to look at viral skin infections here in part two. So first we'll look at papillomaviruses, and of course your eyes go straight to this guy here. This gentleman's name is Day Day, or was Day Day. He passed away about 2 years ago. He has an awful wart papillomavirus infection that has just run rampant through his body. His immune system was incapable of fighting off the papillomaviruses, and so the papillomaviruses just had their way, and they created all of this growth, this massive growth and tissue on his body, uncontrollable, unchecked. His immune system was completely ineffective against these viruses, and if ours were as well, I suppose we probably would look like that too. I assume obviously there's going to be some genetics here, so maybe we wouldn't look exactly like poor Day Day, but yeah, that's what happened there. He had no immunity against it. There's a whole story on Day Day. If you want to Google that, you would type in Tree Man or Day Day the Tree Man, and there's plenty of videos about this gentleman from Indonesia. Gives his story. He went through surgical treatments, and it's a good story. He had a tough time, had a tough life, but he seemed like he was a very gentle guy. But anyway, papillomaviruses. These are wart-causing viruses. There's more than 100 types of them, and it seems like that number keeps increasing as we seem to find and classify them and differentiate these different papillomaviruses, where we're getting up to close to 200 types of them you might find on some from some sources. So how do we treat them? Well, you can freeze them with liquid nitrogen. You can dry them with electrical currents, burn them with acids, topical drugs, injected interferons and lasers, and surgical removal. So you see, you got a pretty vast array of treatments. What does this indicate to us? They're really hard to get rid of. So usually if you got one or two tried and true treatments, that's going to be something that's pretty or relatively easy to get rid of. Well, warts just aren't. So you can use a different number of treatments to get rid of them. I had 9 on my hands. I had 5 on the palm of one hand and 4 on the palm of another hand. They were very difficult to deal with because they were where I held a pencil or a pen. I had all of them surgically removed when I was a kid, and they never came back. All 9 of them gone. I had one hand done 1 week, and then I went back a week later and had the other hand done, and none of them came back. So the surgical removal was a success. So yeah, they're caused by a virus, and they are benign overgrowths of skin, basically. Of course, there are some that are oncoviruses, these papillomaviruses that can cause cervical and penile cancer. And there are about 6 or 8 oncoviral papillomaviruses that we know of. And of course, there are vaccines against them. Smallpox, we're going to look at poxviruses. Smallpox, also known as variola, no longer with us. It was the first eradicated virus. The last case was in 1977, the last natural case, a woman in Somalia. She was the last case of naturally acquired smallpox. A year later, a British researcher contracted it in a lab. He unfortunately died from it in 1978. WHO declared it eliminated from the human race in 1980. So this was the first and only, thus far, eradicated virus. Highly contagious, transmitted via the respiratory route. And so because of its high level of contagiousness, hundreds and hundreds of millions of people, billions of people have died from smallpox over the course of human history. It infects internal organs first, so we breathe it in, infects the organs, and then you get this awful exanthem, which leaves permanent scarring on the skin. We are the only reservoir. Humans are the only organisms that can carry and contract smallpox, and that's why it's an eradicated virus, because we're the only ones. So it doesn't get out into the environment and get transmitted among herds and animals where we don't have control over it. It is transmitted only amongst people. It's a potential bioterrorism agent. It could come back again, and nobody's been vaccinated against it because it's been eradicated for 40 years or a little over, I guess technically, and so nobody's getting vaccinated. Is there a vaccine? Yes, there is. There is a vaccine for it, but nobody's getting it because nobody's getting the vaccine because nobody's getting smallpox. There are two known sites. Atlanta does, Centers for Disease Control, and in a city in Siberia. In 2014, it was found at the National Institutes of Health in Bethesda, Maryland. They were when they were in the process of moving the National Institutes of Health, the facility, down to Atlanta to the CDC. They had found vials in, I don't know. I kind of imagine it being like, in a movie, like they're down in a basement. You got these guys and they're all suited up and they're cleaning out all of these agents, viral and bacterial, and they come across some vials from the 1950s of smallpox viruses. They were viable smallpox viruses from the 1950s. Accidental find. We thought we had them all destroyed. We thought they were only in Atlanta at the CDC, but nope, they appeared here in the National Institutes of Health. That was a big whoops. And it was publicized, the media publicized it, and all but, I think they kept two, I think they destroyed all but two of the vials for experimentation. So this is the reason that's given by both the United States and Russia, that these viruses, the smallpox, is kept for investigation and research. So we'll just have to go with that. I don't want to make any comment on that. It's a potential bioterrorism agent, so it could be, I suppose, used in that sense, but I don't want to say that that's why these two countries are keeping them. We're told that they're kept only for research purposes. There are other suspected but unproven sites. Iraq was a suspected site. France supposedly has smallpox. It's hard to know, but they're unproven sites. Another first about this: it was the first eradicated virus. It was the first disease that a vaccine was developed for by Edward Jenner in 1796. So he saw the association between cowpox and smallpox, and there's a great story about how he discovered that and then developed a successful vaccination against smallpox. So two firsts there with smallpox: first eradicated virus and first one we developed a vaccine for. A long time ago too. In terms of medical history, 1796 and vaccinations, I mean that was a long time ago in terms of medical history. Somebody understanding how to protect the human race against a pathogen. Look at herpes viruses here: chickenpox, varicella zoster, which is human herpes virus 3. So we have human herpes virus 1, which would be cold sores; human herpes virus 2, which would be genital sores; number 3 is chickenpox, and so on. Epstein-Barr is a herpes virus. Cytomegalovirus is a herpes virus. So there are a number of them. There are 9 of them, I think, total. And chickenpox is transmitted via respiratory route, and vaccination was first licensed against chickenpox in 1995. So if you have had the vaccination, you shouldn't get chickenpox, and you probably won't get shingles. However, people have develop shingles from the chickenpox virus. And I've had some students who got the shingles from the chickenpox vaccination. And I've had some students who developed shingles from their vaccination. So they were vaccinated when they were a little kid. And then when they were, in some cases, 12 or 13 years old, they developed shingles from it. Rare instance, but nonetheless, it mustn't be all that rare, because it happened to a couple, actually, of my students that I teach in college. The vesicles become filled with pus. They're highly contagious at that point. And then the virus remains latent for decades in dorsal root ganglia. So I had chicken pox when I was a little guy. I was only, I don't think I was even 2 years old when I got it. I was very young when I got chicken pox. And just this past year, I developed shingles. So that was what, about 46 years later, I developed shingles, which was very painful and unpleasant. But it remains latent in the dorsal root ganglia of the spinal cord. And then they will, the vesicles then will present on a smaller region of the skin. Chickenpox appears over a larger region, and shingles appears in a smaller region. Why can they stay there latent? Because antibodies can't enter the nerve cells. There are no viral antigens present on the surface of the cells, so the HHV3, the varicella zoster virus, is hanging out there undetected by the immune system. And so then it can have a resurgence later whenever the immune system wanes, or there's some kind of emotional turmoil or upheaval, or something happens that then causes the reactivation of these. And they'll travel down peripheral nerves, and then they will travel along what's called a dermatome and present themselves in the form of shingles. You don't get pus-filled lesions, at least I didn't. I don't think you do typically. It's usually red and painful. So shingles, reactivation of it moves along these dermatomes along the skin, and that's what keeps it localized. Usually only seen on one side of the body. However, rarely it is. Shingles does appear on both sides of the body. The reason why it's usually one side is because one side of the cord services one side of the body. But sometimes people have the HHV3 residing on both dorsal horns of the spinal cord, and so it will travel down both sides of the body through peripheral nerves, and then they will appear on both sides. And I do not envy that person. Having it on one side was bad enough. Typically presents around the waist, but may be seen on upper chest, back, or even the face, depending on where these the peripheral nerves, depending on where the viruses decide to travel. It's called shingles not because of what's on the roof of a house. Of course, it comes from a Latin word that refers to a belt, and so you wear your belt somewhere around your waist, and that's why it's called shingles. HHV1 and HHV2. HHV1, those would be our cold sores. It's transmitted via oral and respiratory routes. HHV2 transmitted via sexual contact. So how do these cold sores, they appear, or sometimes we call them fever blisters, which would be vesicles on our lips. Ultraviolet, emotional turbulence, hormonal changes can cause this, and so you develop cold. You're a stressed out college student. You develop a cold sore as a result of that. It's finals week, and you've got papers to write, and so all this turbulence then causes a reactivation of HHV1. HHV1 remains latent in trigeminal nerve ganglia, which are on the sides of our face, and so they will travel down the trigeminal nerves and then appear on the mouth, which is where the nerve terminates. HHV2 remains latent in sacral nerve ganglia, and so that's why it stays down in that region of the body and becomes called genital herpes. Both of them, 1 and 2, may travel to the brain and cause herpes encephalitis. And if it goes untreated, it has a high fatality rate, 70%. So this is a somewhat rare complication of having either one of these two viruses traveling up to the brain and causing encephalitis. Measles, also called Rubella, transmitted by the respiratory route, highly contagious, and you can see on this little guy here, he's got that red macular rash. It's a flattened red lesions on the skin. No inflammation, no pus coming off of those. They're just flattened red lesions. It's only carried by us. We are the only reservoir, so like smallpox, it has the potential to be eradicated. So if we can all get along as one big happy family on this planet, we can then also eradicate this. So there's, a lot of factors that have to come into place. There's a lot of money, obviously, that has to be put out for this. A lot of coordination and cooperation in order to eradicate a virus. I mean, eradicating smallpox, that was huge, to eliminate a disease that had killed billions of people over the course of human history. It's gone. Nobody's dying from smallpox anymore. That's incredible. To do that with measles, that would be as well. Now, measles is not as deadly, it doesn't have a high mortality rate as smallpox, but nonetheless, this would be a huge achievement again. To eradicate a disease from the human population forever that's amazing. Another sign of measles is, and it's a unique sign, they're called Koplik spots, and it's named after a pediatrician. His name was Dr. Koplik, and he noticed that in children, when they were coming to him and presenting with measles, he saw these little spots on the insides of their mouths, around their teeth, along the gum line, and on the inner cheeks. And they were named after him, and it's a very unique diagnostic sign for measles, and they're called Koplik spots, which is an anthem. It's presenting on the mucous membranes in the mouth. It's prevented by vaccinations through the MMR vaccinations, measles, mumps, and rubella. It's not effective before 1 year of age, and so that will equate to susceptibility. So newborns up to 1 year old are susceptible to getting measles. The vaccination just doesn't work because of the poorly developed immune system. The immune system doesn't respond to the vaccination, so no antibodies are made, so it's a waste. So we have to wait until the child is 1 year old, and so this is a susceptibility factor. The cost of the vaccination is only $1. So this could be easily disseminated globally. We could make millions of these vaccinations very, very easily, these vaccines, and then distribute them worldwide and administer them because it's such a low cost. In 1 in 1,000 cases of measles, encephalitis can occur. So this is a complication that can occur as a result of having measles. This is later in life. So this would be one that would appear later. No symptoms, and then decades later, encephalitis develops. Worldwide deaths have decreased dramatically. In 1999, we had 873,000 deaths. You'll notice what's happening, though. We go down to 122,000 in 2012, down to just 90,000 in 2016, and then we upticked to 110,000 in 2017. So globally, the numbers are going up with measles. It's also occurring in the United States, and you can see when the vaccine was licensed in 1963. Once the vaccine is licensed, it's tested on a pretty large population, and then when that population passes, then it's administered mass, and you can see what happens there after 1965. It just plummets. It's like dropping off the edge of the Grand Canyon in the number of reported cases. Huge drop in just a very short period of time. In only about 3 years, the number of reported cases went down that much. In the United States, it was declared eliminated in the year 2000. However, dozens of new cases are imported each year from people coming in from other countries where their vaccination program is not as good as ours, and so they're bringing measles in from as they immigrate into the United States, where they were not vaccinated. So they're bringing the disease with them. Now we have a bit of a problem here. Measles appears to be on the rise in the United States. 2019 had the greatest number of cases since 1992. And this graph you can see here, and this was as of August 22nd of last year, there were 1,215 cases. The final count was 1,282. But look at the previous years. We had an outbreak in 2014 with 667. That outbreak started at Disneyland in California. Now we have this number that's creeping upwards, and this is alarming. It should not be doing this. It was declared eliminated in 2000. There were only a couple dozen cases, and almost all of those there was about 100 and there were only about 140 cases, and nearly all of those were imported cases. But look what's happening. The numbers are going up. Um, it's anti-vaccinations. We have this anti-vax idea and mentality. And so as a result of that, we have people that are bringing in cases of measles from other countries. We have a population of United States citizens who are susceptible now to measles because they're refusing to get the MMR vaccination or any vaccination at all. Um, and so this is going to create an uptick in the numbers. As more and more people choose to not be vaccinated, you're going to see the number of people developing measles slowly creeping up. Because we allow people to come in from other countries where they don't have they have a substandard vaccination program, and they're bringing these diseases in with them. We are developing now a susceptible population, not to mention the infants who are susceptible who can't get vaccinated till a year anyway, and these numbers are going up. So this is something the CDC is watching very closely, and you can check it out on CDC. They have some information that you can read there about what's going on with the alarming increase in measles cases that's happening. Now, 1215 is a very small number out of a country with over 300 million people, but this, as you can see, it's rising, and we've had it so low for so long, and now the numbers are going up. Is there a link between measles, mumps, and rubella and autism? It was purported that it was by a British pediatrician a number of years ago, and found out, and he did recant that. It was proven that his data were false, his findings were false, and still this link between measles, mumps, and rubella and autism persists, and it shouldn't. There's no link between them, and there has been tons of research done that has shown that to be the case, that there is no link between them. So anyway, philosophical decision to not get vaccinated. This is going to create a susceptible population of people because they're just not protecting themselves. Rubella, German measles, or also called 3-day measles, macular rash and fever, it's much milder than measles. We are the only reservoir. This could potentially be eradicated, but people aren't really dying from this, and at least as far as I know, huge numbers. So I don't think we're going to see a global campaign to eradicate rubella. It's transmitted via respiratory route. The major concern of rubella is congenital rubella syndrome, or CRS, which causes fetal defects or death in the first trimester. This was found out, unfortunately, through a number of miscarriages that occurred in the United States, where the discovery of the link between rubella and these fetal defects or death was made. It's prevented by vaccinations, the MMR vaccinations, measles, mumps, and rubella. A couple other skin rashes, fifth disease, caused by this human paravirus B19. Produces mild flu-like symptoms and a facial rash. It looks like their cheeks have been slapped. It's kind of red. Usually occurs in children. This is poor disease. It never really got a name. It's just called fifth disease. It was on a list of diseases that was compiled in the early 1900s. This happened to be the fifth disease on the list. And it just didn't get a name. The sixth disease did. We call it roseola. But it was number 6, and these were skin rashes in childhood. This was a list of these diseases, and so these were numbers 5 and 6. This is caused by human herpes virus number 6 and 7, causes a high fever for a few days and a rash. It's a mild childhood disease. Some people are immune to getting fifth disease because they don't have receptors on their cells for human paravirus B19, and so they can never get fifth disease. What does it look like? That's it. Our daughter had it when she was younger. That's not her, but that's kind of what she looked like. She was tired. She slept quite a bit, and her cheeks were rosy red like that. She had a fever of about 102. Took her to the pediatrician just to confirm, and he's like, yep, it's fifth disease, nothing you can do, just wait it out, she'll be better in a few days. And she was. In less than a week, she was fine. She had a fever for about 3 days and was just pretty tired. She was about 5 years old when she developed it. And then roseola, you can see the macular rash on the back of this child. So that's it for viral skin infections. That's the end of part 2. Part 3 we'll be looking at fungal skin infections and also infections of the eyes. So please stay tuned for that, and thank you for watching.